Good morning, students. Here the module 3 is covalent bond. The valence bond theory is available to watch in the earlier video. You can hear the molecular orbital theory in this session. Now, I wish to provide a thorough description of molecular orbital theory. The instructor of this video is Mrs. P. Arunajyoti, Assistant Professor in Chemistry, St. Joseph's College for Women. One more example for homonuclear diatomic molecule is B2 molecule is formed by the overlap of atomic orbitals of both the boron atoms. A number of valence electrons of each boron atom is 3. In the formation of the B2 molecule, 3 valence electrons of each boron atom, that is 6 in all, have to be accommodated in various molecular orbitals in the increasing order of their energies. Each boron has 5 plus 5 total 10 electrons which can be accommodated by the bonding and anti-bonding molecular orbitals which are present on either side of the atomic orbitals of both the boron atoms. Here in the picture I am not expressing that one is atomic orbital overlapping, but when you are creating the molecular orbital energy diagram, need to represent the 1s atomic orbital overlapping under the 2s atomic orbital overlapping. Coming to the 2s atomic orbital overlapping, it has total 4 electrons. 2 electrons are with the sigma 2s bonding molecular orbital. Sigma star 2s gains 2 electrons. Coming to the next overlapping, that is 2p overlapping. Here the number of boxes in both 2p are 6 boxes. The obtaining boxes in the middle position are also 6. It is a species containing 10 electrons, right? We should use the first code, that is 2121. It is a species containing 10 electrons less than 14 electrons. We should apply the first code, that is 2 boxes, single box, 2 boxes, single box. This code is only applicable for the 2p atomic orbital overlapping. Okay, it is not applicable for the either 2s or 3s or any other s atomic orbital overlapping. Okay, then it can be termed as pi 2px with single electron equal to pi 2py with a single electron. Sigma 2p is a 0. Pi star 2px equal to pi star 2py both 0 0. Then sigma star 2pz 0. Okay, after construction of B2 molecule, then you'll do the bond order calculation. Number of electrons present in bonding is 4. The number of electrons present in anti-bonding is 2. 4 minus 2 by 2, 2 by 2. The answer bond order is 1. The molecule is very stable. Then we can say it has a positive value. The two B2 more atoms connected by the single bond. There are 2 unpaired electrons in a B2 molecule. That is the reason it shows a paramagnetic behavior. If you look at the picture, there are 2 more electrons left over in the bonding molecular orbitals, right? Due to the presence of these unpaired electrons, boron molecule shows its paramagnetic property. It is well known that N2 molecule is the combination of 2 nitrogen atoms. Each nitrogen atom atomic number is 7 and its electronic configurations are 1s2, 2s2, 2p3. 1s level contains 2 electrons, 2s contains 3 electrons, 2p contains 3 electrons. You have to mention nitrogen electronic configuration on one side. In opposite direction, you should mention the electronic configuration of another nitrogen atom. On overlapping of 1s atomic orbitals under the 2s atomic orbitals, you may get sigma 1s with 2 electrons, sigma star 1s with 2 electrons. All these are located at the middle position, you know, right? Coming to the 2s, on 2s atomic orbital overlapping, you will get sigma 2s bonding with 2 electrons, sigma star 2s antibonding with 2 electrons. Nitrogen molecule is a species which has 14 electrons. Then we should use the code 2, 1, 2, 1 for 2p molecular orbitals. You just neglect these codes for s atomic orbital overlappings. Here, two boxes, single box, two boxes, single box. Pi 2px equal to pi 2py. Next, sigma 2pz. Next, pi star 2px equal to pi star 2py. Then sigma star 2pz. Out of 6 electrons which are coming from the two nitrogen atoms, these 6 electrons get spayed up in the bonding molecular orbitals. No more electrons in our anti-bonding molecular orbitals. While writing the electronic configuration of N2 molecule, you should write from lower energy levels to the higher energy level. Sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. Next level pi 2px2 equal to pi 2py2, sigma 2pz2. Okay, this is the way of writing energy order for N2 molecule. Next, on calculating the bond order, you can ignore the combination of inner shells as they have two electrons in both bonding and anti-bonding molecular orbitals. Means either you may include or exclude inner shell electrons while calculation of a bond order. Here, the number of electrons present in bonding molecular orbitals are 6. The number of electrons present in anti-bonding molecular orbitals are 0. 6 by 2 will get the answer is 3. The molecule is very stable molecule since it is a very positive value. The high value of bond order implies that it should have highest dissociation energy. Nitrogen molecule bond order is 3. There is an operation of 3 bonds between the two nitrogen atoms in N2 molecule. Out of 3 bonds, 2 sigma bonds and 1 pi bond need to apply more amount of energy for breaking of the bond between the two nitrogen atoms in a molecule. Since there are no unpaired electrons, the N2 molecule is a diamagnetic substance. As I told you earlier, here there are no unpaired electrons. Due to the absence of unpaired electrons, it shows the diamagnetic property. It is about the N2 molecule. The next example is O2 molecule. O2 molecule is formed by the association of the two oxygen atoms. Each oxygen atom carrying 8 electrons and its electronic configuration is 1s2, 2s2, 2p4. As usual like N2 molecule, here also there is an overlapping occurs between two 1s atomic orbitals of both the oxygen atoms under the 2s atomic orbital overlapping. By the overlapping of 1s atomic orbitals, which generates two molecular orbitals, sigma 1s with 2 electrons and sigma star 1s with 2 electrons. By the overlapping of 2s atomic orbitals of both the oxygen atoms, which generates sigma 2s with 2 electrons and sigma star 2s with 2 electrons. Coming to the 2p orbital overlapping, you should use the code 1, 2, 2, 1. O2 molecule is a 16 electron species, means it contains the electrons more than a 14 electron species. That is the reason we must use the code here 1 single box, 2 double box, 2 double box, 1 single box. Both the 2p atomic orbitals of the two oxygen atoms contains 4 plus 4, 8 electrons. Out of 8 electrons, 6 electrons went into the bonding molecular orbitals. The remaining 2 electrons appeared as unpaired electrons at the pi star 2px and pi star 2py anti-bonding molecular orbitals. Then, how to write the energy order? You should go from lower energy levels to the higher energy levels. Sigma 1 is 2, sigma star 1 is 2, sigma 2 is 2, sigma star 2 is 2. Next, sigma 2pz2, pi 2px2 equal to pi 2py2. Then pi star 2px1 equal to pi star 2py1. After writing of energy order for O2 molecule, calculate the bond order. Number of electrons present in bonding molecular orbitals are 10. Number of electrons present in anti-bonding molecular orbitals are 6. 10 minus 6 by 2, you will get 4 by 2. The bond order for O2 molecule is 2. The molecule is very stable since it is a positive value. Bond order 2 implies the presence of a double bond in O2 molecule. There are unpaired electrons. That is the reason O2 molecule shows paramagnetism. Due to the presence of unpaired electrons, O2 molecule exhibits paramagnetic property. The last example for homonuclear diatomic molecule is Ne2 molecule. How do you form Ne2 molecule? You can form Ne2 molecule by taking two neon atoms. Each neon atom carrying 10 electrons and its electronic configuration is 1s2, 2s2, 2p6. All the atomic orbitals of each neon is fully occupied. On either side of the atomic orbitals, you can write the molecular orbitals at the central position. Each neon has 10 electrons. 10 plus 10 total count is 20 electrons, which are located at the bonding and anti-bonding molecular orbitals of neon atom. Of all the electrons gets paid up, no more unpaired electrons in Ne2 molecule. Then you should write the electronic configuration, that is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, pi 2px2 equal to pi 2py2, pi star 2px2 equal to pi star 2py2, last sigma star 2pz2. Bond order is number of electrons in bonding is 8. Number of electrons in anti-bonding is 8. 8 minus 8 by 2. The answer is 0. The bond order for Ne2 molecule is 0, which implies that absence of bonds between two neon atoms in Ne2 molecule. It is about the MOED of Ne2 molecule. The examples for heteronuclear diatomic molecules are CO, NO, CN, Cn- and NO plus ion. Coming to the next slide, here both the CO and NO molecules are the examples for heteronuclear diatomic molecules. Means here we have to identify the number of bonds existed between our two dissimilar atoms. In case of CO molecule, you have to identify the number of bonds between carbon and oxygen CO molecule. In case of NO molecule, you'll find out the number of bonds existed between nitrogen and oxygen in NO molecule. Coming to our first example, CO molecule, carbon has 6 electrons, whereas oxygen has 8 electrons, total 14 electrons. All these 14 electrons from carbon and oxygen distributed all over the bonding and anti-bonding molecular orbitals of 1s, 2s and 2p levels. Okay. On one side, it is an atomic orbital indication regarding carbon atom. On the other side, it is an atomic orbital indication regarding oxygen atoms. On either side of the oxygen atomic orbitals, you have to write the molecular orbitals. All the electrons occupied in CO are 14 electrons. They get sped up. Then it has no unpaired electrons. Coming to the writing of energy order. How to write energy order? Sigma 1 is to sigma star 1 is to sigma 2 is to sigma star 2 is to pi 2px2 equal to pi 2py2. Then sigma 2px2. We'll just stop it. There are no more electrons. Okay. This is the way of writing of energy order. Then what is the next thing? Bond order. Calculation. Number of electrons present in bonding molecular orbitals are 10. Whereas the number of electrons present in anti-bonding molecular orbitals are 4. 10 minus 4 by 2. 6 by 2. The answer for CO molecule, bond order for CO molecule is 3. Due to the presence of paired electrons, it has the diamagnetic property. Okay. Aside from the CO molecule, there is a NO molecule. On one side, it is an atomic orbital indication regarding nitrogen. On the other side, it is an atomic orbital indication regarding oxygen atom. Nitrogen has 7 electrons, whereas the oxygen atom has 8 electrons. Total number of electrons occupied in the NO molecule is 15 electrons. Okay. All these electrons distributed in a bonding and anti-bonding molecular orbitals at 1s level, 2s level and 2p levels. You may get fractional bond order here for NO molecule. Number of electrons present in bonding 10. Number of electrons present in anti-bonding molecular orbitals are 5. Okay, here one electron left over in pi star 2py1. That is the reason you may get the bond order in fractional bond order. Okay, 10 minus 5 by 2 equal to 5 by 2 equal to 2.5. Okay, due to the presence of unpaired electron at the anti-bonding molecular orbital in NO molecule shows paramagnetism. It has a paramagnetic property. It is about the CO molecule and NO molecule. All the images in this video have been taken from Google Chrome. Thank you.